Thank you guys so much for waking up early with me today. I know it's tough, especially when you've been hitting the karaoke a little too hard or enjoying all the finest craft cider Portland has to offer. So thank you so much for kicking off day 2 with me today. Now, today we're going to talk about bridging in React Native. And this is a pretty heavy topic, so I hope you all have had your coffee this morning. I know I have. So first, I'd like to introduce myself. My name is Peggy Rayzis, and I'm a software engineer at Major League Soccer on the UI team. I write a lot of React Native code, both for our Greenfield React Native app and also our real-time match experience on the web, powered by universal components. I also really love bridges, both of the React Native and the real-life variety, and you'll see some cool bridges in my slides today. So, all right, now that we got all the introduction out of the way, let's start breaking down bridging. Now, I'm going to use bridging as a verb a lot this morning, and what I mean by that is how we communicate between JavaScript code and native code in React Native. So, how many of you, just show of hands, would consider yourself a JavaScript developer? Okay, a lot of you guys. I consider myself a JavaScript developer too, and I think anytime we start venturing into native code, coming from a JavaScript background, it kind of feels like this. It feels really scary, and the learning curve is really steep. Now, this is actually a real bridge in Japan, by the way. And I'm from New York, I don't really drive that much, so the thought of this is super terrifying. But today we're going to make bridging feel more like this. Now, don't get me wrong, it's still pretty scary. You're dealing with unfamiliar languages and concepts, but once you learn a little bit about the mechanics and some tools to make it easier, you'll start to see it from a new perspective. Now, luckily, you won't have to reach for bridging too often. That's why awesome tools like Create React Native App and Expo exist. Now, for most simple applications, you don't need to write native code. Even for most complex applications, you won't have to write native code too often, but it is useful to know how in case you have to. Now, just to put it into perspective, here's a language breakdown of our React Native prototype we built at the end of last year. This is for a greenfield application, so if you're brownfield, your statistics might look a lot different. Now, for us, the vast majority of our app, 77%, was written in JavaScript. The other 23% were native UI components and modules, about evenly distributed between Obj-C, Swift, and Java. Now, this is where bridging comes into play. In order for your native code to talk to JavaScript, you will need to write a bridge. Now, although bridging shouldn't be the first solution that you reach for, there are some situations where writing a bridge is necessary. First, you need to integrate a third-party SDK. Now, at Major League Soccer, we have a video platform that didn't have a React Native SDK, so we had to bridge the iOS and Android SDKs ourselves. If you're doing any sort of video compression or image filtering where performance is really important, you're probably going to want to move that to native and write a bridge module for it. If you're building a brownfield application and reusing native UI components that you previously wrote, you'll probably be bridging quite a bit. And also, if you need access to platform APIs, something maybe like the camera or the phone's gyroscope, you will need to use an open source library or write a bridge yourself. So, I firmly believe that the key to understanding bridging is cracking into React Native internals. Now, too often we treat abstractions as a black box and don't try to see what's underneath the surface. Now, show of hands, who knows what the message queue is in React Native? Okay, not many of you, and that's okay, because I'm going to teach you guys about it, and I'm also going to demystify some of the magic behind the React Native bridge in hopes that it will help you learn bridging faster. So here's a very basic cross-platform overview of the threading structure in React Native. So on the native side, we have the main thread, which is responsible for UI. We also have the shadow queue, which is responsible for layout calculations. Another important thing to note here is that each native module has its own thread, or in the case of Android, they share a thread pool. Now we also have a JavaScript thread, and the way these two sides communicate is through the bridge. So the JavaScript thread actually knows about all of your native modules at runtime. They're injected into the JavaScript context of the VM as a global variable. Now, don't worry if this sounds really confusing. It's going to become a lot more clear later. Just try to remember that there is a JSON representation of each native module that looks like this to the bridge. So now we're going to dive a little deeper into the mechanics of the bridge. So when you interact with a React Native application, all touch events start on the native side. Information about the touch event passes through the bridge, where the JavaScript side reacts to the information. In fact, all communication passes through the bridge. Now this includes everything from creating views to network requests, re-rendering a component, and more. And this is why it's really important to understand what's going on, because it touches so many facets of your application. So all communication across the bridge is asynchronous, which is why you have to communicate via method calls and callbacks. Another thing to note about the bridge is that all messages must be serialized in order to pass across. Updates are also batched to improve performance. Now, if you want to create some sort of mental map in your head, this communication channel is pretty similar to a client and a server, for example. So all of these messages are handled by what's called the message queue, which has a native part and a corresponding JavaScript part. Now, the JavaScript part is really what we care about when it comes to performance. If everything is getting passed through this message queue on the JavaScript side, we need to make sure that the JavaScript thread isn't blocked and that the message queue isn't congested. So if it is congested and the JavaScript thread is blocked, we enter this really weird situation, and maybe some of you have experienced this before. We can scroll through the UI because that's all done natively, but JavaScript doesn't register our touch events. So if you're experiencing performance issues in React Native, I'd venture to say that it's probably related to the message queue. So how do we get visibility into this, and how do we prevent it from happening in the future? So one of the best ways of preventing message queue congestion is limiting passes over the bridge. This is actually what the React Native team did recently with useNative driver for animations. First, you send the configuration over to native the first time, so that way you don't have to keep passing information across the bridge. Another thing you're going to want to do here is keep your data flat. Try to avoid nested objects and arrays, because you're just going to have to use conversion methods to use the data in native. You're also going to want to keep the data lightweight here. Don't try to send images encoded as base64 strings over the message queue. That's really going to slow your application down. Another thing you're going to want to do is write your business logic on one side, and that's going to help you limit passes across the bridge. If you're unfamiliar with native languages, my suggestion would be to keep your native modules thin and then write most of your business logic on the JavaScript side. Another thing you're going to want to do to gain visibility into what's going on with the bridge is to utilize logging and profiling tools. And I'm going to teach you guys more about that today. So let's dive into some tools that will make debugging the message queue easier. So here's what a message looks like. Every single message sent over the bridge, whether it's a network request or you're creating a view, has this exact type signature. So first you're going to have a type, and that's a number that maps to whether you're communicating from native to JavaScript or JavaScript to native. You're also going to have the name of the module, the name of the method, and any arguments passed to that method. The message queue also has a spy function that you can hook into to console log the messages passing through. So here's an example of what this looks like in our prototype at Major League Soccer. So here a user is tapping on a video, which renders a video view and plays it. you can see here that the touch event actually starts with native. Now, this spy feature is pretty chatty, and it's kind of hard to read and tell what's going on here. We need a better way to isolate the specific messages that we're trying to debug in order to gain visibility with what's happening over the bridge. So that tool that's going to help you accomplish that is called RNSnoopy. I just want to give a shout out to Dotan Nadehom, who created it and did an amazing job with this tool. It actually uses RxJS and treats the message queue data as a stream, so you can filter out the noise and focus on what's really important. So one of the cool things that you can do here is filter based on module or method, so you don't get all that chattiness when you're trying to inspect what's going on with the message queue. Another really cool thing that you can do is trigger a yellow box warning in React Native if messages cross a certain threshold. So in this case, we're showing a yellow warning box if we're passing too many arguments to create view, which is something that could slow your application down. Okay, so now that we know more about what's going on behind the scenes, we're going to jump into how we bridge native modules and UI components. So first, you're going to choose your language. Now, if you're building an open source library, I recommend sticking with Obj-C and Java, as they're the most widely supported. You can also choose Swift and Kotlin if you'd like. I like these two languages because they most closely resemble flow-type JavaScript, so I feel a little bit more in my comfort zone when I'm working with them. And actually, I want to digress for a moment to talk about Kotlin, because I think it deserves some attention on the big stage today. So recently, first-class language support was added for Kotlin was added to Android. It's super easy to set up. It's only about 2 lines that you have to add to your project, and you can convert any Java file to Kotlin with the click of a button. The runtime library is less than 1 megabyte, so it won't add a significant amount to your bundle size, unlike Swift, which adds, could be anywhere from 3 to 7 megabytes. Also, unlike Swift, it works with React Native Link. Well, not yet exactly. The pull request was recently merged, but this should be landing in a future version of React Native very soon. So anyone who has ever set up native navigation by Airbnb knows how rough it is to not have React Native Link support, so this is really huge that this has landed for Kotlin. Another really exciting thing about Kotlin is that first-class support for iOS is coming soon. So while we won't be able to share native modules completely because of differences in threading across platforms, we'll be able to reuse business logic, which is really exciting and should be a huge time saver. So first, I want to break down the difference between native modules and UI components, because this was something that confused me when I first started doing bridging tutorials. So the first thing you're going to want to choose is whether you want to build a native module or a UI component. And most of the time, you're choosing one or the other. A native module does not render any UI. It just exports methods and constants. Now, occasionally, you'll need to integrate both. Perhaps maybe you're building a video player view that also exports play and pause functions. But this becomes really complicated because of how threading works in React Native. So first, we're going to learn about bridging UI components. Now, in a previous version of this talk, I had a lot of native code samples, but it felt a little aggressive for a 9 a.m. talk slot. So I'm going to spare you guys today, and I'm going to teach you some high-level concepts that can be applied across platforms and show you a tool to make writing bridge modules a lot easier. So whether you're building for iOS or Android, you're going to have to construct a view manager. Now, the view manager is what orchestrates the interaction between JavaScript and the view. It's a factory that creates your view, and only one instance of the view manager is created per bridge. So remember how I told you before that the bridge knows about all native modules at runtime? Well, the view manager is like a special kind of native module, except it returns UI and runs on the shadow queue. The bridge has a reference to it, and it has information about the component name and any constants if you're exporting them. So on the JavaScript side, if we want to construct a view, we call require native component. And that's what tells the view manager to create the view. Now, it also checks the component's interface via prop types to make sure that we aren't passing in any incorrect types to our component. So now, the view manager, it creates the view. It also stores a reference to the view instance on the bridge so we can use it on the JavaScript side. And finally, in order to display the UI, we render our native view and just use it normally as we would any other React component. So, all right, that was a lot of information. So let's recap what we just talked about here. So here's what's most important to keep in mind when you're bridging a UI component. Only one instance of the view manager is created per bridge. The view manager is a factory that creates a view, and it's where you declare your constants and any props that your component will use. This actually includes event handlers as well. So any type of event handlers, you're going to want to set those up in your view manager. In this case, the manager acts as a delegate for all of its view instances when handling events. Just like in React, our view is where we hook up lifecycle events, like layout subviews, for example. And if you want to render any children, you're going to want to do that in your view. So, okay, so we got UI components out of the way. Now let's talk about native modules. They're actually a bit easier than UI components because they just export methods and constants. In fact, a native component is a special type of module that returns UI. So, like we learned earlier, all native modules are global variables at runtime. They're represented by the JSON above, and they include any methods and constants defined on the module. So, when we invoke a method on our module from JavaScript, we send a message to the queue with the method name and any arguments, just like that type signature that we saw earlier when we were spying on the message queue logs. The native side is what calls the method directly. And if there is any information to pass back to JavaScript, the method can do so either by a callback, a promise, or sending an event through an event emitter. All right, so let's quickly recap everything we just talked about. Only one instance of the module is created per bridge. Now, this instance is initialized at runtime. And if you want to communicate any data from native to JavaScript, you can do so with either callbacks, promises, or emitting events. If you want to communicate data from JavaScript to native, you call methods on the native module and pass in any arguments, which then transfers that message to the message queue. Now, since JavaScript already knows about the module's constants at runtime, accessing them is synchronous, and you won't have to go through the normal bridging process. So that was a lot of information here, and I think no matter if you have a solid understanding of React Native internals or if you're just getting into it, bridging can be very prone to error, and here are some reasons why. So some of the pain points associated with bridging is you're constantly context switching between different languages and different files. There's also a ton of boilerplate. You have to remember to subclass from certain RCT view managers, or in the case of Android, you have to override certain methods. And it's kind of confusing to get all this boilerplate straight. The instructions are also really piecemeal. You have some examples in the documentation, but you don't really have a one-stop shop where you can get all of your information. It's kind of scattered throughout various blog posts and tutorials. There's definitely an opportunity to improve the documentation here. So after experiencing all of these pain points firsthand, I wanted to find a better way. I also wanted to create a tool to make bridging seem a lot less daunting for JavaScript developers, because it seems intimidating when you're first getting into React Native and you suddenly have to write native code. So I created React Native Create Bridge. It's a CLI tool that generates bridge module and UI component templates in the language of your choice. So the CLI is really easy to use. You'll globally install it from npm and run create bridge in the root of your project. From there, the prompts will walk you through a series of questions. You'll specify your module name, what type of bridge you want to create, and which languages you want to support. And before you know it, you'll have customized bridge templates that look like this. Another thing I want to point out is that I include links to the docs so you can read more in depth if you're interested. Now, this was to make it as simple as possible for JavaScript developers to get started with bridging. But I plan on adding a configuration option soon to remove the comments for more experienced users. So React Native Create Bridge isn't the only tool like this out there. I would also like to recommend the awesome work of Johann Stein with React Native Create Library. There are a few key differences with our tools, however. Create Library is only intended to scaffold open source libraries. It does not generate templates for UI components. And while Create Bridge was originally intended to be used in existing React Native projects, it also works for scaffolding open source libraries. I actually just recently talked to the Shout'em team. They used it for their Shopify bridge and had a really great experience that they wrote a blog post about. We also differ a bit in the languages we support. So if you need to support Windows bridging in your project, Create Library is a really great choice. And this is a feature that I plan on adding to React Native Create Bridge soon. If you want to get a little experimental and try Swift and Kotlin, Create Bridge supports that too. And if there are any features that are important to you all when bridging, please get in touch. I'd love to hear from you all about how you're using Create Bridge. I want it to be a one-stop shop for bridging, so your feedback is really important to the success of the project. So that was a lot of information, but I want to leave you all with one more thing. I think sometimes when we start venturing into unfamiliar territory and languages, we need a little bit of confidence booster. So don't be afraid to get your hands dirty and crack into the React Native internals when dealing with native code. I think now you're equipped with the tools and knowledge you need to make this happen. So you got this. Thank you guys so much. I had a really great time sharing my work with all of you. If you have any questions, please feel free to get in touch on Twitter or come find me later. Thanks.